What to do today is take a look at the difference in means for a t-test. With your samples and data from this, most of you are using the states. You're going to be looking at a t-test for the difference of means between quartile 1 and quartile 4. This is in some ways the easier threshold to reach. You could be looking at the difference of means between quartile 3 and quartile 2. You would expect those to be closer together. So the first thing is simply to identify that you want quartile 1 and quartile 4 as we do in step 1. The second thing then is to summarize quartile 1 and quartile 4 based on the mean, the sample size, and the standard deviation. Have those summary data available. The next thing you want to do is state the null hypothesis. Our null hypothesis is always that is one of equality. In other words, that Q1 and Q4 aren't different. And what we're going to do is to seek to reject the hypothesis or the idea that they aren't different. And that alternatively implies that indeed they are different or that they're unequal, so that the mean of Q1 is not equal to the mean of Q4. The fourth step then is to actually fill in the data we need for to estimate t, the t value, and that t is equal to Q1 minus Q2 over what we call here the joint variance. And this, we use the joint variance in cases where we have less than 30 observations for either our group 1 or our group 2, in our case Q1 or Q4. We also would decide on a decision rule. Now, in this class, we are going to have a simple decision rule, which is that any time that our estimated t from part 4 is greater than 2, we will reject the null hypothesis that the first mean is equal to the second mean, or Q1 mean equals Q4 mean. Go ahead and run the numbers at that point, and I'm going to have a video to show you how to just do that in Excel. And then if we actually had a more elegant we've already had our decision rule, so you actually don't need to do number 7. But if you were interested, you could go to table E and Quirk and Cummings and look and find the critical value for t based upon the degrees of freedom you have. The degrees of freedom means sort of how much data do you have, and the larger the degrees of freedom, the lower the t value necessary to reject the null. And so in this case we have and it's calculated as simply the number of observations in group 1 plus the number of observations in group 2 minus 2. The minus 2 comes from the fact that you've calculated the mean for Q1 and the mean for Q2. And so you lose a degree of freedom in doing that. If you're using quartiles of states, we might have 12 states in Q1, 13 states in Q4. So you would have 12 plus 13 minus 2. You have 23 degrees of freedom. You would then state and evaluate the result of our estimated t from part 4 up here, or part 6, against what's in table E. Again, in our case, we're going to sort of cut to the chase and use 2 as the standard rejection level. Anytime t is greater than 2, we'll go ahead and reject. That's our rule, just to make our lives easier. And that allows us to say that indeed there is a difference, a qualitative difference and a statistical difference between Q1 and Q4. So I hope that this has been helpful. And again, more to follow, and we'll work with that.